So this question is adapted from 2009-2010 main semester examination number 21 of Obafemi Awolowo University Physics 102. The question shows a diagram of charge Q1, Q2 and Q3 at a certain distance. The figure above shows 3-point charges that lie along the x-axis. The magnitude of the net electrostatic force on Q1 is. The question is asking us to find the magnitude of the net electrostatic force. The net electrostatic force on charge Q1. Identify your charge. My charge Q1 is in the middle of the other two charges and is of value or magnitude Q1 is equals to plus 3 microcoulomb. The magnitude of Q2 is equals to minus 4 microcoulomb, while the magnitude of Q3 is given as minus 7 microcoulomb. To find the net force acting on Q1, I must firstly find the force of attraction between Q1 and Q2. The force between Q1 and Q2 is attraction because they are of opposite charges. Recall, unlike charges attract. Thus, the force of attraction between Q1 and Q2, which is represented as F on 1 due to 2, can be calculated using Coulomb's law. So with Coulomb's law, I will say the force is equals to K magnitude of Q1 multiplied by the magnitude of Q2 over the distance between Q1 and Q2 R square, which is given as 0.20 meter. The force is equals to 9.0 times 10 raised to power 9 Newton meter square per coulomb square multiplied by 3 times 10 raised to power minus 6 coulomb multiplied by 4 times 10 raised to power minus 6 coulomb over the distance between Q1 and Q2 given by 0.20 meter square. If you punch your calculator, you are going to obtain If you punch your calculator, you are going to obtain 2.7 Newton. This is F on 1 due to 2. To find the force F on 1 due to 3, that is F1, 3, which is equals to K magnitude of Q1 multiplied by the magnitude of Q3 over R square. The R here, let me notify it as R1, 2, R1, 3, the distance between 1 and 3. This is equals to 9.0 times 10 raised to power 9 Newton meter square per coulomb square. Q1 is given as 3 times 10 raised to the power minus 6 coulomb. Q3 is given as 7 times 10 raised to the power minus 6 coulomb over 0.20 meters square. 0.15 meters square, because we are taking the distance between Q1 and Q3, not Q1 and Q2, not Q1 and Q2. It is Q1 and Q3. If you punch your calculator, you are going to obtain 8.4 Newton. Now, to find the net force, we need to know the direction of each forces. For Q1 and Q2, that is F of 1 due to 2, we observe that Q1 will move in the direction of the negative x-axis towards this direction, because it is an attractive force between the two. Q2 will tend to attract Q1, making Q1 to move towards this direction. So Q1 will tend to move towards this direction. F of 1 due to 2. Between these two, Q1 and Q3, it is also an attractive force, making Q1 to move in this direction. F of 1 due to 3. The net force is equals to, since they are moving in opposite direction of x-axis, I'm going to take the difference of the two forces. F of 1 due to 3 minus F of 1 due to 2, which is equals to 8.4 Newton minus 2.7 Newton. If you take the difference of the two forces, you are going to obtain your net force as 5.7 Newton. In the net electrostatic force, on Q1 is 5.7. Since F of 1 due to 3 is greater than F of 1 due to 2, the net force will move in positive x direction. The net force in the positive x direction, because the rest of the force, 5.7 Newton, will move towards the positive x direction. Thank you.